Time is the fourth dimension, along with three spatial dimensions. The universe doesn't care about time, so human beings were those who invented clocks and calendars to measure time. How we measure time depends on humans entirely. There is a significant problem with human beings. Have you ever heard something that is called a human factor? Yes, that's right, we're unstable, with hard-to-predict behavior. Human factor causes many problems. For example, people tend to think about time locally. Unfortunately, it's not always correct to think about time in the local perspective. I'm writing these words in the morning, but it doesn't mean that it's morning everywhere on the planet. It sounds like I'm saying obvious things, but believe me, we tend to forget about everything, including such obvious things, when programming. Programmers very often just blindly call DateTime now and pass the result to the user. It doesn't work well in many scenarios. So, to determine what time is it, we at first should know whose time we want to determine. Where does it last? So, such terms like today, tomorrow, yesterday, and names of days like Monday, Tuesday, or specific days like January 1st and so on, all these notions have a local perspective. It means that Monday for one person is Tuesday for another one. Today for one person is tomorrow for another one. People like to change rules. A very long time, people measured time by using the Julius calendar. It is called Julius because Julius Caesar introduced it. There was a problem with that calendar system. It accumulated one excessive day every 128 years. That happened because the length of a year in Julian calendar was 365 and quarter of the day, what is greater on 11 minutes than the length of a tropical year, also known as a solar year. Pope Gregory VIII introduced another calendar which fixed that problem of accumulating one excessive day every 128 years. Gregorian calendar was introduced in 1582 on October 4th. The Gregorian calendar had to eliminate all the accumulated excessive days immediately. So after the 4th of October in 1582, the 15th of October goes. Can you imagine something like this in modern days? 10 days are just gone. There is no the 5th of October in 1582. According to the Gregorian calendar, days from the 5th to 14th of October inclusively just don't exist. Do you know what is more funny? There are more than 40 calendars we're aware of. Armenian calendar, Aztec calendar, Byzantine calendar, Indian national calendar, Hebrew or Jewish calendar, Masonic calendar, Chinese calendar, Islamic calendar, and many others. The majority of them have forgotten long ago, but at least 5 calendars are active and many people measure time relying on them. Here are they. Of course, the Gregorian calendar, Islamic calendar, Hebrew calendar, Chinese calendar, and Indian national calendar. I'm actually sure some other calendars are still alive. By the way, taking into account that the 5th of October in 1582 doesn't exist, how do you think what will happen if we write the following code in C# using standard BCL library? If you thought that there would be an exception, you are wrong. Nothing bad will happen. That date will be created successfully. Why is this so, one might ask? And the answer is quite simple. The default calendar behind the date-time structure is the Gregorian calendar, and the Gregorian calendar is the so-called Proleptic calendar. Proleptic means that we pretend like the Gregorian calendar was always in effect, so all dates are still there and they are all valid. As I already said, not all the problems are related to human beings. Some of the problems are caused by the universe itself. Even children know that there are 60 seconds in a minute. So if you're a smart guy, answer the following question. How do you think? Is it possible that 1 minute can last 61 seconds? If yes, why? I say no, it's impossible. But what do you think? And here is the answer. Have you heard about leap or so-called coordination seconds? The thing is that the rotation speed of Earth is not constant. It slows down a little bit, and from time to time we need to introduce that leap seconds. Sometimes we introduce them once in a year, sometimes once in a couple of years. Why is this important? The importance of such things depends on the case. For coordination of events in space, it might be very important to keep track of leap seconds, especially in high-frequency scenarios. Most people are not concerned about leap seconds and even have never heard of them. That's because no one cares of such timing precisions. But you, as a programmer, always have a chance to stumble upon problems related to time measurement. Everything depends on the type of software you are working on. For example, in 2016, December 31, at 59:59:59 p.m., the next tick will set the following time. In reality, the universal coordinated time will just pretend that the last 59th second in the year lasts 2 seconds instead of 1. Do you think that no one cares about leap seconds? If you think so, then you are wrong. Your clocks on your PC take into account those leap seconds, since they are synchronized with UTC. The NTP stands for Network Time Protocol, is a protocol of time synchronization that makes PCs all around the world aware of leap seconds. Synchronization of clocks sometimes plays a very important role in people's lives. Here's an example. Did you know that a day on Mars lasts for 24 hours and 40 minutes? So, people who observes and controls the rover on Mars have to wake up 40 minutes later every day to keep their lives in sync with the life of that rover. This is because the rover has to operate at certain hours on Mars. Can you imagine how hard it is to live such lives? People eventually end up waking up at night. It is just plain craziness. Okay, in the next lecture you'll learn how a computer stores time and what precision it supports.